Hi everyone, this is your struggling CS student and today I'll be doing another LeetCode problem. Let's take a look at today's problem. LeetCode problem 1422 maximum score after splitting a string. Given a string S of zeros and ones, return the maximum score after splitting the string into two non-empty substrings, left substring and right substring. The score of splitting a string is the number of zeros in the left substring plus the number of ones in the right substring, okay? All possible ways of splitting splitting S into two non-empty substrings is as such. Uh, okay, okay. Yeah, I think what what you need to do to solve this problem is essentially keep track of two sets of windows. You have the left window and the right window. And initially, you can just initialize the right window to the entire string, calculate the number of ones in the right window, and as you iterate through the string, you can just maintain the counts of zeros in the left window, and you should be able to uh, get the maximum score, as long as you keep track of the count of zeros in the left substring as well as the count of ones in the right substring. So I think we can just do just that. The implementation might be a little bit tricky, but I don't think it's that bad. So what I can do is, in Python there is a data structure that comes with the language, which is a counter, and it's essentially a dictionary that counts the frequency of the elements inside of a particular iterable, for example, like a string. So you can say count is equals to counter of s. This would be the entire right side of the window. Then you can say for C and S. So as you iterate through the string, you have to keep track of the left window. So I guess we can initialize that as, let's call this right window. This is the left window. This initially will be nothing. Then you would say left window plus equals. Hold on a second. But how do we get the count? How do we get the count? Oh yeah, actually maybe we don't have to use the counter. We can just iterate through it twice. Okay, but we still need to keep track of the right and the left window. Right window is equals to 0. Left window is equals to 0. So for C and S, if C is equals to 1, this is the right window. Let's initialize the right window first. So now we have all of the right window. For C and S, if C is equals to 0, 0, else, guess initially the score would be, let's call this the score. So initially the score is just the right substring because you don't have any left substring. So yeah, what we can do is left window plus equals 1, else right window minus equals 1. Then we can do score is equals to max of score of left window plus right window. Score. I think that should be it. Okay. Answer. Oh, okay. I see. This is a case where initially, okay. That means it's a little bit lazy, but yeah. How do we handle the case where it's all we have to at least split once, right? Yeah. So how do we do this? I guess we can start with the right window as such. So this is the right window. So our right window always starts at index 1 till the end instead of starting from index 0. So let's roll with that. So right window is 0, left window is this. So for I in range, the length of S, starting from 1. This is the right window. So initialize the right window, then we iterate through again. No, we have to keep track of the left window already in this case. That means we will say left window is 1 if s of 0 is equals to 0, else it's 0. So right window is 0 initially, then we have to initialize the right window, and the score, likewise, score has to be the left window. 1 if s of 0 is equals to 0, else 0, okay, yeah. Then we go through from index 1. This is when we are including this character, and then we take the score. Is this correct? Oh, C, let's see. C equal s of I. C equal s of I. Okay. Looks fine, but yeah, it's a bit wacky. Let's have another test case. This is all zeros. What bits? 1, 0, 0, 0, 0, 1. Or the other way around. Okay. That's because of the right window, is it? 1, 2, 3, 4, 5, left window. Wait, hold on. Why is that? What's the score here? Score is 1. That's correct. I see. Okay, we need to go up to the end. We need to go up to the end. Let me test again. I think that should be fine. Yeah. Okay. Alright, submit it. Alright, it's accepted. Nice. So what's the time and space complexity? The time complexity is O(n), and the space complexity is just O1. Yeah, because we are not initializing any data structures. We're just using a few variables to keep track of the maximum sum and the count of the various zeros and ones in the left and right window. Yeah, just maintaining their counts. So let's take a look at the time complexity is O(n) and space complexity should be O1. Yeah. How about editorial? Is there any smart way that they do this? Brute force? Yeah, okay. Yeah. Count left zeros, yeah. I think that's pretty much it. One pass. Oh, there's a one pass way to do it. Okay. Huh? Oh, interesting. Okay. Count the ones. I also count the zeros. Zeros minus ones. Okay. Yeah, possibly. Gonna read this a little bit more later, but yeah. And that's it for me. Thanks for watching.